Hi, and welcome back. Now that we've seen how the training process works in the previous video, we'll go through the practical aspects in this video. So let's start by loading the prepared datasets and have a look at the first 5 rows with the following instruction. So we can load our prepared dataset. So this prepared dataset have been saved with the saved instruction. The df.csv will save our initial data frame into a new dataset with that name. So now we can load this dataset here and get the first 5 rows. After execution, we can see that we have this dataset in the first 5 rows. And it's very important to know that to be able to train our model, we need to have in one side all the features that will be used for prediction. And in our case, it's all the columns except the diabetes column. Our features will be non-pregnant, which is the number of pregnancy, to age, except the diabetes one, because this is the column we'll be using, we'll be trying to predict. So let's get all the features in the feature variable with the following instruction. So with that following instruction, we get from the prepared dataset, which is the dataset here, and we drop the diabetes column, except we get all the column by dropping the diabetes one. So this will get all the features from non-pregnant to age except the diabetes column because we dropped the column here. The axis equal 1 means that we're getting the column vertically, so we get all the features except diabetes 1. And then after we get all the features, now we can get the target one. So as I previously said, the target column is only the diabetes columns. And let's have a look at all our columns. By looking at our columns, we can print all the columns here, all the features. And so we have number of pregnancy, glucose count, diastolic BP, thickness, insulin, BMI, diabetes rates, and age. We can see that we got all of the features here in the form of lists. And now we have the features and the targets. The next thing to do before splitting the data is to get the values of each features and the corresponding target values. So since we'll be using a mathematical model, we also need to have a mathematical representation of our data. So this representation is a matrix. So we can easily get the matrix representation of the following of the features and the targets with the following instruction. So we define x variable which will contain the values of the features, and y which will contain the values of the targets. So let's print the x value to see. Oops, I did not execute it first. So first execute and then print it. Now as you can see, we have a 8 by m dimensional matrix with 8 corresponding to the number of features. The number of column here, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have 6 here, but we have in total 8 because the 3 dot means that we have remaining columns. So we have 8 by m dimensional matrix. And by m, I mean the number of observation we'll be having here. So this number can be seen here by showing the shape of x. So we can see x shape. So we have 768 observation and 8 columns, and these 8 columns correspond to the number of features. We can do the same with y. So we have shape. So this shape is also 768 observation, and here we can notice we have nothing. As we have nothing, it means that we have one dimension. So this is a one-dimensional matrix. So I can say that we're now ready to split the dataset. So in order to split the dataset, we need to import the train test splits module. So we can import the train test split modules with the following instruction. This instruction will help us in order to split the dataset into train and test. Now, to be able to split the dataset into train and test, we can use the following instruction. This is the training dataset, the test dataset. This will correspond to the training label, and here is the testing label. I mean, by label, I mean the targets. So this is the training targets and the testing targets. The train test split will take in parameters our training dataset our original dataset, and the original targets, and split according to the percentage we'll be giving here. So we say that we use 0.30 for the test size. By using this value, we will have 30% of the original dataset in the training set, and yeah, the remaining 70% will be in the training sets. We have 30% in the test and the remaining 70% in the training sets. So the random state here is that value which will ensure that we get the same value in the training and test states every time we'll be running the codes. So yeah, everything is going right. So let's run this. So to make sure we have the value in terms of percentage we want, we can run this instruction. So we can see that we have 70% that went into the training set and the remaining 30% into the testing set. Yes, we have already all the data sets, the training and the testing sets. Now we can create our first model. This first model will be the naive-based model object. So to be able to create this naive-based model, we need to import from the sklearn naive base. So we import the sklearn naive base model from the sklearn module. Now that we imported the model, we can now create an instance of naive base model with the following instruction. Create the model equal naive Gaussian naive base. So we will have the model in this instance. Now run it. So now that we create here the model, we now need to train the model. So to be able to train the model, we use the fit function on the model name. So by running this instruction, we will take the training dataset and the training corresponding label in order to train our model using the fit instruction. So with that, our model is already trained. Now we can get the metrics. How can we now use the dataset and the model to get the metrics? So we first need to import the metrics from the sklearn module. The first metrics we'll be using is the accuracy. So the accuracy is the total number of good prediction made by the model divided by the total number of observation we have in our dataset. So now, in this part, it will be the total number of observation in the training dataset, since we'll be using the training sets here. So we get the accuracy here, and the training accuracy, we get the metrics and take the accuracy score function that will be applied to our yes, we have it here. So first of all, we need to have this prediction. So take the prediction of the model. The model need to make a prediction first. So after we make a prediction on our training set, we can now get the accuracy. Now execute this one. And then we can finally print the prediction, the accuracy of our model. Now we can see that the model made a prediction with accuracy of 78%. Now we can get the same with the testing dataset. To be able to get the model prediction with the testing dataset, we use the following instruction. So it's important to notice that we never ever train on the tested dataset. So we only make the prediction and get the accuracy on the test set. So this is the prediction we made. Now we can get the accuracy made by the model. So we can do the same, likewise we did for the training set, and get the test accuracy for the test model. And we can see that the model made a prediction of 78% on the test data. So this is how we can train a model on the training data set and make a prediction and also evaluate its performance on both the training data sets and also the testing data sets. And in the next videos, we will see how we can train other models like logistic regressions and other machine learning models in the next videos. So thank you and goodbye.